Hello students, we're going to be going over significant figures today. Significant figures are also called sig figs, and they are the known digits in a measurement. By known, I mean that these are the significant figures that are shown by the measuring tool you are using. Remember that any measurement should come with a unit. If we look at these pictures, the top ruler tells us that the paper clip is somewhere between bigger than 2 centimeters and smaller than 3. It tells us no more than that. By looking at the bottom ruler, we know that the paper clip is between 2.3 and 2.4 centimeters because it has more markings. Now the bottom ruler is better to use in a lab. This is because it has more significant figures visible. In the laboratory, we need to be as accurate as possible. Therefore, the more significant figures you have, the more accurate you're being. Here we have different tools that we use in the laboratory to measure volume. However, in the far left we have the graduated cylinder, and this will give us the most markings and therefore the most significant figures. Thus, it will lead us to the most accurate measurement of volume. You'll notice that we use that a lot in the lab. That's not to say that we won't be using the Erlenmeyer flask and the beaker as well on the right, but these don't have as many markings. All right, there are 4 rules to determine how many significant figures there are. The first one is that all non-zero digits are significant. So for example, any digit 1 through 9 that is not 0 is significant. As an example, 43.55 centimeters has 4 significant digits. 03.54 centimeters only has 3 significant figures. Rule number 2. All zeros between non-zero numbers are significant. Between 2 non-zero numbers or sandwiched, for example, 101, there are 3 significant figures in that number. We count the 0 because it is being sandwiched between 2 non-zero numbers. Another example, 105.3 centimeters. Here, the 0 is between 1 and 5, so all 4 digits are significant figures. 3,004 kilometers. Now we have 2 non-zero numbers sandwiching 2 zeros. So all 4 again are significant figures. 87.05. Notice there's a decimal there, but it doesn't matter because that 0 is between a 7 and a 5, which are non-zeros. So all 4 digits will be significant figures. Rule number 3. Leading zeros are not significant. The zeros that come before non-zeros are not significant. For example, 0.0000 203.5 milliliters. Here there are only 4 significant figures, shaded in red. The front zeros do not count. These are leading. Another example is 0.000025306 milligrams. Here there are 5 significant figures. Even with the decimal point, the front zeros or leading zeros do not count. Rule number 4. Trailing zeros are significant, but only when there is a decimal point. Trailing means they come after the non-zeros. For example, 8,000 millimeters. There is no decimal point here, so there's only one significant figure. Another example, 750 with a decimeter. With a decimal, centimeter. Here there are 3 significant figures because that decimal point is there. 0.002500 kilometers. Here there are 4 significant figures. The 2 out front do not count, but the end do. All right, here are some more examples. Let's identify the amount of sig figs. Very good. 3, 7, and 1 are non-zeros, so all 3 are significant figures. 6,250 with a decimal point. Because that decimal point is there, there are 4 significant figures. 0.0054. Here, the leading zeros do not count, therefore there are only 2 significant figures. 0.000540 centimeters. Well, here the leading zeros still do not count, so there are only 3 significant figures. Now, uncertainty, another new word. This is the idea in science that sometimes our equipment is unable to measure what we are studying. This happens frequently due to equipment markings not actually matching what we are measuring. This is seen as something being between 2 marks on a measuring tool. For example, if we look at the meniscus in these 2 measurements, take a look at this sticks measurement. For measurements with uncertainty, you still need to record a number for them. First, you will record as much as you can read, then you will record what is called the uncertain digit. The rules differ based on what tool you are using. For a graduated cylinder or a thermometer, if the liquid stops between 2 lines, put a 0.5 on the end of your measurement. If it stops on the line, put a 0.0 on the end of your measurement. For a beaker or flask, if the liquid falls between 2 markings, record the volume as the average between the 2 markings, rounded to the nearest 10. For a ruler or a meter stick, if the length of something falls between 2 markings, put a 5 in the hundredths place. Example, 7.15 centimeters. If the length falls exactly on a line, put a 0 in the hundredths place. For example, 7.10 centimeters.